Hi, I'm Sarah Soul from Georgia Tech. I have a question for Harrison. When you were looking at the modeling for your ice deposits for the velocity, and you said you were only looking at 7%, was there any reason why you weren't looking at larger percentages, or is that something that's or non-homogeneous mixtures?
Sorry, that the 7% number that I was quoting is like the total weight percent in the model. So locally within the model, depending on the specific implementation, we had 4 different versions of the model, but the ice content within the pore space of the regolith varied all the way up to 100%. So,
Okay, thank you.
and globally in the model, it was 70%, but locally it varied.
Okay, thank you.
Hi, Alicia Jyoti, UCLA. I have a question for Nick Schmer, for the cold spots. Is there a size limit where the seismic shaking hypothesis would not be strong enough to form a cold spot? And would you be able to distinguish that with like the resolution limit of Diviner?
I mean, we picked the 300-meter cutoff because that gets us down to about a pixel size, but presumably smaller cold spots exist. And the question is how much shaking would be produced by the impact if it's large enough to actually extend past that sort of ejecta blanket. And I think it cuts off somewhere around maybe 10 to 100 meters, somewhere in that range, where the ejecta blanket still is over where the cold spot shaking could have been produced. So, but yeah, there should be a smaller size limit.
I have another question. No one else. Yeah. So is there like if the regolith is flopping up, do you see like a roughness difference?
That's a good question, and I'm not a diviner expert, but presumably if you are shaking the regolith, you're going to change its structure a little bit, right? Especially if you have like these fairy castle structures at the surface. I think there is some evidence from the diviner team that those are being disrupted by around the cold spots. So yeah, probably, but we're talking like a few centimeters here. So anybody have a camera out there that can look at millimeter scale?
Panelists can also ask each other questions. I'm just saying. Also, have you looked at cold spots in radar? They're actually really pretty.
Sorry.
In radar. Well, getting at the roughness question, because they do appear radar bright, and you can trace some of those beautiful filament-like features out.
Let's look at them together.
Let's do it.
Since nobody's standing up, I'll ask Erica a question. So you when you said there was oriental ejecta, at that distal end of those rays where the Hevelius was seen, what if you're seeing into the radar, what fraction of the material is actually ejecta? What fraction is local? And it's just kind of the oriental did some mixing and stuff.
I mean, that's the question, the massive unconstrained question that I didn't talk about. It seems like whatever mixing happened, it was not necessarily excavating or bringing up any rocks, any large blocks from depth, or if it was not in a proportion enough to make radar bright craters in that area. And I don't know that mixing, like you kind of presume that mixing would be sort of similar. I mean, maybe, I don't know. We can talk about that, but there is still that broad change in the backscatter signal. That again, it doesn't necessarily look like that is from some sort of variation in the block population. So this nebulous composition radar loss thing is what we're thinking about now, but it's totally open-ended what that actually means in any more specific way. So if anyone knows what any other radar loss sources are, it would be great to talk about.
Erica, you want to stay up there? We've got a question from online.
Sure.
Tom, can you unmute?
I'm sure. I think I'm unmuted.
Yes, we hear you.
Excellent. In 2002, Hawk et al. Identified a single dark halo crater near Marilicus. It was about 130 kilometers away, so right in that area. So does a single anomalous crater like this fit in with your observations?
Okay, so this gets to the hidden chapter of my talk that I had to cut for time, where this gets back to the point of maybe that radar brighter region is from the presence of cryptomare. So Mike Sori in the late aughts identified this really broad scale positive Bouguer anomaly that would be consistent with a cryptomare deposit. And B-Ray had that paper where there was one dark halo crater in the region. So that would support that maybe there's a buried lava flow there. After that, Jenny Witten in 2009-ish did a very dedicated, thorough search for cryptomare everywhere on the moon, including that area. And she said that there was not sufficient data in multiple corroborating data sets to support the presence of a buried lava flow in that area. So Jenny sort of crossed that one off the list, and probably there is not a large cryptomare deposit in the area. Since there's no one standing up here, I will say that Tab Preisel was also looking at that same area and found that that's one of the areas where there could have been an eruption or intrusion of some pink spinel anorthosite, part of the MG suite. There could have been some non-mare volcanism or plutonism maybe in that specific Maurolycus area. So it's this really cool area that maybe it's not cryptomare, maybe there's some plutonic stuff in the subsurface. There's a lot going on there, in addition to all the basin stuff that I talked about.
Cool. Thank you.
Questions in the room?
Oh, sure. Yeah, thanks. So I'm Jacob Richardson at NASA Goddard, now in Albuquerque. Caleb, you sort of gave a shout out to Nick on the provenance of rocks near scarps, and then you also were sort of ended by saying, hey, these South Polar rocks are really neat, but who knows what they're sort of genetically related to. I'm wondering, are they maybe genetically related? And I thought I would just ask if now that we have both of you on the stage, maybe there's a bit of where do rocks come from, man, that you could each spend like 30 seconds on. I don't know.
So I will say there's this awesome de Gerlache scarp that was pointed out by Tom Waters. I bet Nick was on that paper, a bunch of other people, that does have these rocks exposed in one of the Artemis landing areas. And Tom and Nick and others have said, it could be active, right? Like that's one of the things that having all these rocks there implies. I would rather just go there and look at those rocks personally, but I don't know. But my point, I guess, is that I don't totally understand the mechanism that this tectonism brings rocks to the surface, because you actually see, like in Lee Lincoln's scarp at Apollo 17, that it cuts across regolith. I don't get that. Okay, like why do you have this what looks like a brittle motion through a material that's like 100 micron grains? I'll give it to Nick.
So I'll bring up something that one of our graduate students within geodes has been working on over in astronomy. This is Joe DiMartini, who's a student of Derek Richardson's, and he's been playing around with these models where if you shake a poorly sorted distribution of particles, and you all know this because you've probably played with a bottle of mixed nuts. It's called the Brazil nut effect. You can get the bigger particles that come up to the surface if you give a little bit of a shake to this material. It's something we see in the asteroids under microgravity, which is what Joe's been studying. But for the lower gravity environments of like the moon, it's also possible that shaking of a regolith could cause the bigger particles to come up to the surface. And so maybe in the vicinity of faults or fault scarps where you've got maybe shaking episodes integrated over hundreds of millions of years as these fault scarps forms, that you bring some of the rocks up to the surface because of the bigger particles and they float up. That's total speculation, but it's something that we know from the physics of how grains move around when you give them impulse from seismic shaking. So I don't want to put everything under the seismic shaking category, but the moon does experience shaking pretty much everywhere on the surface, because wherever there's an impact, it's going to locally shake that environment. And the codas of this means that the energy is diffusive. So these things are not just shaking for a few seconds, they're probably shaking for the order of minutes to hours. So that might be an unrecognized mechanism. I don't know, throw it out there.
On the asteroid side, The Brazil nut effect only works over a few, like a pretty restricted depth, right? It's not like you're exhuming stuff down from the base of the megaregolith or anything. It's like
Particles have
a
to be free to
few
move.
particles deep, right? Depending on some other things. So you need to have some blocks in the relative near surface to begin with.
Yeah.
Right.
Yeah, just to add, there's a great paper by Catherine Eldar arguing that there's blocks in the regolith, and I think she's right. So yeah.
Alicia Josie again. I have a question for Harrison. The 3D like rock ice scans was so cool. Are you planning on doing the same like analysis that you did for seismic? Are you planning on doing it with GPR as well?
Yeah, actually, we are doing some dielectric measurements using TDR in the lab that go along with it. We don't currently have the capability with our X-ray transparent cell to do in situ dielectric measurements, something we're definitely interested in. And another thing that I didn't mention for lack of time during the talk is that the lunar conditioned cell is available for general user proposals at the Advanced Light Source, which is a user facility. So anyone can write a proposal to get some time there, and I'm happy to talk more about that process if anyone's interested.
Thanks.
I've got a question for Patrick. The relationship you found between tubes versus channels was really cool, and I was wondering if you had thought about whether that relationship would change on the moon with different gravity, different, no atmosphere, like do things tunnel over, roof over sooner with no, I don't know. Had you thought about that? Do you expect to see the same ratio on the moon?
Yeah, I've thought about that a little bit, but not enough to say much, except for the certainly the gravity is going to be a part of it, and then the pressure that the lava tube feels, or the lava feels inside a tube, is probably not much different, because it doesn't communicate really with the atmosphere, except for I would imagine for thermal reasons, right? You've got atmospheric convection on Earth that's really helping to cool, but you've got radiation that's kind of dominating on the moon. And so I think the thermal modeling of lava flowing in a tube that I've been trying to get funded with Susan Sakamoto over the years. I think that work is going to help us figure out sort of what are the forces in these tubes that are important for shape. And then we can say a little bit more confidently, like whether these ratios are going to directly apply to the moon or Mars, or what needs to be changed for them. But for now, like finding them is on Earth is kind of where we're at.